This quick guide tutorial from Exocad shows how to design a reduced crown with a milled brace support by using the telescopic crown restoration type and the shrink telescope's anatomy feature. To save time, the tooth placement and the anatomical design have already been done. We proceed to the telescope's insertion axis step. Define the telescope's insertion axis. I've already saved a custom view with the desired insertion axis. This insertion axis will not only be used for the milled lingual, but also for any attachment that might possibly be attached to the construction. Let's proceed to the next step, which will be the design of the milled brace support. The telescope parameters will be explained in a separate tutorial. Now I will demonstrate how a milled lingual can be designed very quickly with the telescopic crown restoration type. I usually start with the lower border by adjusting the points on the lower curve. Tip: with Shift you can move a whole region limited by 3 points, or move each point individually. You may use the semi-transparent anatomical crown to define the border thickness in the region of the milled lingual according to visual judgment. Or use the dot below the control point to stick the border's point to the anatomical shape. I prefer to do it for these cases manually, and to make the borders slightly bigger than the crown in this region, as the anatomical tooth will be bigger in the upper region of the crown. When the border is done, proceed with adjusting the friction area. Start with using Control to move all points simultaneously inwards on the middle curve, in order to ensure the friction surface is as thin as possible. Now add another point with Control in the mesial region to prepare the design for a beading where you want to stop the porcelain. Do the same in the distal area. Now move all points in the buccal area of the lower curve towards the margin to eliminate any additional border in this zone. Now use again the semi-transparent anatomical crown to adjust the thickness of the crown in the ceramic beading areas. If required, add a third control point to create a flat area in the zone where you would like to add attachments later. Repeat this step on the distal side. If you want to place a milled channel later, add enough material in the region where you'd like to place it. Most technicians like to design a chamfer on the occlusal beading of the ceramic to pave the way for a smooth transition between the partial's metallic brace and the ceramic. This can be achieved with the upper curve. Move all points with Control to move and place the upper curve with a constant distance to the friction area, or use Shift to place the beading individually by using the transparent anatomical mesh. Now click on the UFO cone icons between the upper and middle curve to change the state for this segment from conical to friction surface. That creates a second friction surface, which has the same chamfer as set in the main friction surface. Now we proceed with the most important step in this tutorial, the definition of the anatomical zone, which shall then be reduced. To do this, we click again on the UFO icons in the occlusal area and change the state of these segments to anatomic shape. Now it's the right time to do some fine tweaking for the distances of the chamfer on the ceramic beading area. Furthermore, we also have to define the anatomical zones to be reduced in the buccal area. To do that, we click on the hat icons, this time in the buccal area, to change the segment state to anatomic shape. In the second friction area, you have to click twice on the UFO icon to switch the segment state to anatomic shape. You can find more information about the usage of the UFO hat tooth icons in the Exocad wiki. You can extend the chamfered zone in the area where you possibly want to place a milled channel at a later stage, and do some adjustments in the transition zone between metal and porcelain. Now proceed to the free-forming step. The first free-forming step has the advantage that the friction surface segments stay untouchable. That allows you to add some material on the anatomic segments to improve the transition zone between metal and porcelain. But don't be too critical, as these regions will be reduced at a later stage. That's how the finished crown will look like later with porcelain, but now we want to reduce the anatomical area. To do that, we switch to the Expert mode and click on the Shrink Telescope's Anatomy button in the Expert frame on the bottom of the screen. The telescopic segment's friction surface and conical shape will be automatically marked in blue and will thus be excluded from shrinking. Only the anatomical segments will be shrunk. Certainly, you can adjust the blue area manually with a brush, or delete blue parts while holding on Shift. Use the slider or control and the mouse wheel to adjust the brush thickness. The blue friction area cannot be deleted as long as Hold Friction Parts is checked. If this feature is unchecked, you can even delete the blue area on the friction surface segments. If checked again, these parts will automatically be marked in blue again. As for reduced crowns, you can now set the desired depth of shrinking. You will find more information about the other shrinking parameters in a separate basic feature tutorial called Anatomic Coping and Cutback. Now, click the Apply button to start shrinking. And here is the result. Click OK to close this dialog, and you can proceed in the wizard. The wizard will restart with a second free-forming step on the reduced restoration. Still, free-forming on the friction segments is not possible yet. These zones stay untouchable. You may benefit from this advantage to add or remove material in the beading zone. If you want to do some free-forming or smoothing on the friction surface segments, you can do that in the last free-form restoration step once you've reached the end of the wizard. Now you can, for example, smooth the borders which were created between friction surface segments and the reduced part. Or simply smooth sharp edges on the top beading. Please note that as for now you are allowed to freeform the friction surface segments, you can deform these parts or their parallelism. And here is the finished design. You can now continue and add some attachments or cut some milled channels if required. This will be explained in a separate tutorial called New Attachment Feature. Thank you for watching this video.